In this video, we are going to learn microservice communication types, which are the synchronous and asynchronous communications. Client and services communicate with each other with many different types of communications. Mainly, those types of communications can be classified by two axes, synchronous and asynchronous communication. That you can see the picture on the slide. This is the synchronous communication illustration. Client directly send requests to the basket microservices, and microservices can be communicate with each other synchronously using the HTTP gRPC communication. And here you can see the asynchronous communication that provide the asynchronous communication with using queues. Let's start to talk about synchronous communication. What is synchronous communication? Basically, we can say that synchronous communication is using HTTP or gRPC protocol for returning synchronous response. The client sends a request and waits for a response from the service. So that means the client code blocks their thread until the response reaches from the server. The synchronous communication protocols can be used HTTP or HTTPS. In synchronous communication, the client sends a request with using HTTP protocols and waits for a response from the service. So that means the client calls the server and block client their operations. The client code will continue its task when it receives the HTTP server response. So this is the important topic, that client block their code when synchronous to calling, and after receiving an HTTP server response, it's continue their task. So this operation called synchronous communication. It has advantages and disadvantages that we would consider when we pick this way. But now I am going to continue to what is asynchronous communication in microservices. Another communication type is asynchronous communication. So what is asynchronous communication? Basically, in asynchronous communication, the client sends a request, but it doesn't wait for a response from the service. So the key point here is that the client should not have blocked a thread while waiting for a response. The most popular protocol for this asynchronous communication is AMQP, which is the Advanced Messaging Queue Protocol. So with using AMQP protocols, the client sends the message with using message broker systems like Kafka and RabbitMQ queue. The message producer usually doesn't wait for a response. This message consumed from the subscriber systems in asynchronous way, and no one waiting for response suddenly. An asynchronous communication also divided by two according to implementation. An asynchronous system can be implemented in a one-to-one queue model or one-to-many topic model. So now let's elaborate this. So I'm going to start with the one-to-one queue model. In one-to-one queue implementation, there is a single producer and single receiver. So we can give an example one-to-one queue implementation as a command pattern. In command pattern, it is offers to receive one queue object, and after that execute the command with incoming message. This process restarts with receiving new command item. You can see the image on the slide, which is representing the one-to-one queue communication. This is implementing command pattern. Basically, the queue receives the message from the basket and send the message to the product microservices, and product microservices consume this message one-to-one queue model and process the message, and after that receive another message from the basket microservices. This is one-to-one queue model. And now we can continue another model. Another asynchronous communication is one-to-many topic implementation. In one-to-many topic implementation has multiple receivers. Each request can be processed by 0 to multiple receivers. One-to-many topic communication must be asynchronously. So we will see this communication with the publish subscribe mechanism used in the patterns like event-driven microservice architecture in the upcoming section. Basically, an event bus or message broker system is publishing events between multiple microservices, and communication provided with the subscribing these events in asynchronous way. Kafka and RabbitMQ is the best tool for this operation. You can see the image in here. Basket microservices publish a message to queue. This will be subscribed several microservices that consume these events from the queue. This is the one-to-many topic communication. So microservice-based application will mostly use a combination of these communication styles. So if the client application waiting response from the services, then we use synchronous communication with HTTP protocols by exposing RESTful APIs into microservices. If the client doesn't wait any response, then we use asynchronous communication with message broker event buses like Kafka to provide decoupling between microservices. As you can see that we have understand microservice communication type, which are the synchronous and asynchronous communication, and microservice based application will often use a combination of these two communication styles. So we will also design our e-commerce architecture with using both communication types. But before that, let's elaborate the synchronous communication and underlying mechanism.